In this video, we're going to look at finding asymptotes analytically. That is from the function, not just by looking at the graph. If you don't know what an asymptote is, then you should look at my previous video on what asymptotes are and how to find them from graphs. So, a vertical asymptote occurs when we try to divide by 0 in a function. These results must be excluded from the domain because we can't divide by 0. So let's have a look at this first example. The vertical asymptote here is what happens when we want 0 on the bottom of the function. That is, when x minus 5, the bottom of the function, is equal to 0. Rearranging this, we get the equation of the asymptote is x equals 5. So the vertical asymptote here occurs when x is equal to 5. The horizontal asymptote occurs as x tends to infinity. Now this is a difficult concept to understand sometimes. What happens as x gets really, really, really big? And that's all we have to do to find the horizontal asymptote. So let's consider this example. What happens as x gets really big? Well, as x, we write this as a little arrow, that means tends to infinity, gets closer and closer and closer to infinity. Obviously it can't actually equal infinity, but it can get closer and closer to infinity. So as x gets closer and closer to infinity, what happens to this function? Well, y becomes approximately, well, when we're dealing with x being so ridiculously large that it's nearly infinity, plus 3 makes no difference. So on the top, we just got pretty much the x, because it's so ridiculously large, the plus 3 doesn't make difference. And similarly on the bottom, the minus 5 doesn't really make a difference, so we just get an x on the bottom. And that simplifies to 1. X over x is 1. What that means is, our horizontal asymptote is a y equals 1. So let's take those two methods and see them through these other three examples. The second example here, the vertical asymptote, that's when the bottom, 3x minus 2, is equal to 0. Again, we can rearrange this to find the vertical asymptote is x equals 2/3. The horizontal asymptote, we find that as x tends to infinity, gets really, really close to infinity. So as x gets ridiculously large, y is about, well, the plus 3 doesn't really matter, so we've just got 2 times x. And similarly, the minus 2 doesn't really matter, it's insignificant compared to such a big number of x. So we get 3x on the bottom. But again, the x's cancel out, and we get 2/3. So our horizontal asymptote is y equals 2/3. In this third example, our vertical asymptotes are when x squared minus 4 is equal to 0. Now we have a quadratic here, so we have to solve this by factorizing. And you should recognize that this is the difference of two squares, x minus 2x plus 2. So our vertical asymptotes are at x equals minus 2 and x equals 2. There's two vertical asymptotes here, minus 2 and 2. Now for the horizontal asymptote, we let x, so as x tends to infinity, what happens? Well, as x tends to infinity, we have y is equal to, the minus 3 is insignificant compared to the 4x, so we just get the 4x, and the minus 4 is insignificant compared to the x squared, so we just get the x squared. This should of course here be approximately equal to, really, not is equal to. And here we can cancel the x on the top with the x squared on the bottom, and we get 4 over x. Now 4 over x isn't our asymptote here. We have to think, we were talking about what happens when x gets really, really large. So what happens here is x gets really, really big, Well, if the denominator of a fraction gets huge, the number itself becomes tiny. Imagine if we're doing 4 over 10, and then 4 over 100, 4 over 100 is much smaller than 4 over 10. 4 over 1,000 is even smaller. 4 over a billion, tiny. 4 over 3 trillion, really, really, really tiny. So this number here, the 4 over x, is getting really, really small. That is actually tending to 0. I want to have a space here. Tending to 0. That means that y is equal to 0 is our asymptote, because 4 over x gets closer and closer to 0 as x gets bigger and bigger and bigger. Now this final example, the vertical asymptote, is when we have 2x squared minus 4x equals 0. Again, we have a quadratic, so we have to factorize. This time, 2x x minus 2 gives us that the vertical asymptotes are x equals 0 and x equals 2. The horizontal asymptotes are as x tends to infinity, what happens? Well, as x tends to infinity, y is approximately equal to, well, the minus 3 is insignificant, so we have 5x cubed, and minus 4x. Now, we have an x in that minus 4x, but an x compared to an x squared is insignificant. Imagine 10 compared to 100. 100 compared to 100 squared, which is 10,000. The 100 doesn't have much, isn't very significant compared to the 10,000. A million compared with a trillion. Huge difference there when we square them. So the 4x is actually insignificant here, so we end up with just the x squared on the bottom. Again, we can cancel, the 2x squared cancels with the x cubed on the top, which gives us 5x over 2. Now what happens to this as x tends to infinity? Well, this one actually also tends to infinity. As x gets bigger and bigger and bigger, 5x over 2 also gets bigger and bigger and bigger. It's huge. What this actually means is there is no horizontal asymptote in this example, because as x gets bigger and bigger and bigger, the value of y continues to get bigger and bigger and bigger. It doesn't get closer to a single number. So that's how we find asymptotes analytically. If it's a vertical asymptote, we make the denominator of the rational function equal to 0. That will tell us our vertical asymptotes. And for horizontal asymptotes, we have to consider what happens as x gets closer and closer and closer to infinity, and it gets bigger and bigger and bigger. Now, we do also need to consider what happens as x gets smaller and smaller and smaller, gets closer and closer to negative infinity. In these cases, the asymptotes, the horizontal asymptotes all stay the same. But sometimes, when we come to sketching graphs, which we'll look at in a future video, we need to consider that, because it will depend which side that it's approaching that asymptote from the graph when we're sketching the graph. So we'll have a look at that in a following video. But in this one, what you need to take away is how to find vertical asymptotes and horizontal asymptotes by using the bottom of the fraction equal to 0 for vertical asymptotes, and for horizontal asymptotes, consider what happens as x gets ridiculously large and how that affects the function.